Hello everyone, welcome to Java Tutorials. My name is Kishore. In our last video, we discussed what is an abstraction and how it is useful in an object-oriented programming language, and also the two ways you can achieve abstraction, that is using interface and another is using abstract class. In this video, we will discuss how to use the interface to achieve abstraction. What exactly interface is? It is a contract that sets rules for multiple classes to follow, which means when there are multiple classes, all the classes should follow some rules, like it must have the methods with this particular signature. This should be the return type. So such kind of rules is going to be provided by the interface, and interface will only provide method declarations, that is methods without body or methods which will not have any logic. Interfaces will not have constructors. It means you cannot create the object on the interface. Then whatever the variables you create in the interface are going to be final by default. Final means they are constants. You cannot change the value of the variables inside the interface. As there are no constructors, obviously someone should initialize the variables and you have to explicitly initialize. Because of that, only it is made final. So once you initialize, it cannot be modified. Then everything in the interface is going to be public by default. Whether it is a variable or a method declaration, everything is public by default. There are certain changes done from Java 8 onwards, like they added default methods, static methods in the interface. Discussing that in this example is going to be confusing because we should first understand the purpose of interface. Then, if I discuss what are default methods and static methods, then you can understand why they are adding these features like default methods and static methods. So, in the upcoming tutorials, we will discuss about the changes done in the interface from Java 8 onwards. Now, in this video, we are going to discuss about the interface as it sets rules for multiple classes to follow. Let's take an example of like I want to maintain the data in different ways. Like I want to add the data, I want to remove the data. Suppose there are three different requirements, and I tell three developers to implement those three requirements. Then I would say developer one, you implement add method so that it has to add like a stack and remove like a stack so that last in first out. When you add the element, the last element you add should be the one that needs to be removed. And developer two, I tell you add and remove element in such a way that add and remove should be in sequential order, like which element you added, that you maintain in the sequential order and you remove the element in the same order. Then for developer 3, I say you implement the add and remove. The add should only allow unique elements. It should not allow duplicates, and remove the elements in insertion order. When there are three different requirements, developer 1, developer 2, developer 3 can create add and remove methods in whatever the way they want. One developer can write add method, another developer can write store method, and another developer can write create method. They are going to create three different methods. I don't want these developers to create the methods like this. I want them to follow some rules. So I would say that follow this interface, which is a contract that will tell how the add method should look like and how the remove method should look like. So that is what the interface does. It is a contract that is going to set the rules for multiple classes. And let's create one interface now with the name called data structure, and we will create two methods here, add method and one more is the remove method. And notice add and remove do not have the flower brackets which are opening and closing flower brackets, because inside the interface, you only write method declarations. Then whoever is implementing the data structure interface, the rule is they need to implement all the methods of the interface. Suppose developer 1 wants to implement the interface in a stack format where last in first out. Last in first out means the element that is added at the last should be the one that needs to be removed. Means what he does is going to write stack data structure implements data structure interface, and this data structure which is implementing the data structure, that is the stack ds, is getting an error because the rule is whenever a class implements an interface, it has to provide method body for all the methods. There are two methods, so what you should do, you just place cursor over the error. The Eclipse is going to show you a hint saying that add unimplemented methods. You can just click on it and look at the add method and remove method. They are having public keyword because the add and remove are by default public, while overriding that public is retained. I am not going to actually write the logic of add and remove because we need to create array, then we need to use counters to increase the index. Then for remove, we need to remove the element and we need to reinitialize the array by reducing the size. All those things are going to be an hectic job. We just need to understand the interface. For that reason, we will only simply print the statements telling that add in stack. Then the remove from stack. Let us create another class. Assume that it is implemented by developer 2, that is class list data structure implements data structure. Once the class implements the data structure interface, it has to implement all the methods present in this interface. And what are those two methods? Add and remove. Let me select that add unimplemented methods, and add and remove methods are added inside that class also. We will implement the add method and remove method just by printing a statement called add from list ds, and the remove method will remove from the list ds. And one last class we will create. Assume that that is created by developer 3, and we will name that as unique list ds, and that is going to print add is going to be unique list ds and remove from unique list ds. This also implements data structure. Notice all the three classes have the same add and remove methods, but they are going to do the add and remove in a different way. And what we need to understand is one developer might call the add method and remove method from stack. Another developer might call add and remove from list.ds, and one more developer might call add and remove from another implementation, that is unique list.ds. And if any changes is done in any of the implementations, the developer who is invoking the add and remove will not change his code. That is what we should understand. So let us treat that developer as a developer 5 who wants to call the add and remove from different implementation. Let's say he is going to call add and remove from which one? Maybe stack ds. So what he can do is he can use the reference of data structure, which is an interface like this, and he can create the object of stack ds. Notice the reference variable name, that is ds, is of data structure type. It is an interface. We are not creating the object of interface. We are creating only the reference of the interface. but this is the object we are creating. So the data structure is a higher type, then the stack is the lower type. We know the concept that higher type can always take the lower type. But can I create the object of data structure? Let me try to create the object of data structure. And what happens if I try to create an object of data structure? You can see there is an error. It says cannot instantiate because the interface doesn't have the constructor. We can't create the object of the interface. Let's say we are going to call the add method and remove method. And what happens is the add and remove method will be invoked on the stack ds object. So my output is going to be add in stack and remove from stack. The same reference can also take the object of list ds as well as unique list ds. And I can still invoke the add and remove method from the same reference, but this time it is going to invoke the add and remove on the list ds instance. If I run this program, I should see add and remove is invoked from list ds. Then lastly, I can also give the object of unique list ds, and if I invoke the add and remove, this time it is going to call the add and remove on the unique list ds instance. So consider developer 5 is one part of the code which doesn't need to be modified in case the add and remove changes. If the implementation of add and remove changes in any of the class, the developer 5 who is invoking the add and remove doesn't need to bother about changing these codes because the developer 5 knows what add and remove does. But he might do some other things, probably like after adding it, he might notify to the end user that data is added. After removing, he might notify to the end user that data is removed. Those jobs he will do, but he will not worry how the add and remove is implemented. Let me try to change something like add from stack. And if I run the so I am doing changes only in the stack ds. If I run the program, it should reflect to the caller. So automatically it is reflecting to the caller. So the purpose of the interface is it is going to set the rule how the multiple classes has to implement, and it is also like a contract so that the end user will know what the method does, but the end user will not know how it is implemented. By that, it is going to achieve the complete abstraction. So the real use case of interface is think that this add and remove method is invoked by some 10 different developers. All their code is not going to be changed if the changes happens to the add and remove. That is what the real advantage you get with the help of abstraction. They are not forced to do the changes in their code if the changes happens to the add and remove method implementation. Probably some kind of fine tune needs to be done to the add and remove method means that is done by some other developers, not by the caller. So in the next video, we will discuss about how to achieve abstraction through abstract class. See you in the next video. Thank you so much.